This is Exmoor in North Devon. Hidden away from the busy world, it's a place to escape the hectic pace of city life. Exmoor is filled with stunning scenery. There are rugged landscapes to explore, open country to walk through. There's a slower pace of life with time to unwind. To find it, take a map of Britain and zoom into the southwest along the coast of the Bristol Channel. This is where you'll find the Exmoor National Park. Then look closer and you'll discover two villages, Lynton and Lynmouth. They almost touch but are separated by a height of 500 feet. On that steep slope, you'll find the Cliff Railway. It's a clever piece of Victorian engineering that's been running for more than a century. And the way it works, the ideas behind it, and the machinery that makes it run are fascinating. The railway draws people to it. Throughout the summer, hundreds of people travel up and down the line every day. And for many, it's the highlight of their visit. Just standing and watching the cars ascend and descend can be mesmerizing. But why was it built? Go back in time to the end of the 19th century, to the days before the Cliff Railway existed. Boats arrived in Lynmouth carrying coal, food and lime to improve the local soil for farming. But getting these heavy loads to Lynton meant transporting them up steep paths using horses. Fortunately, George Newnes visited Lynton in 1887. A wealthy philanthropist, he owned a vast publishing empire. During his visit, George stayed with a lawyer, Sir Thomas Hewitt, who explained that there were plans for a cliff railway using the latest 19th century technology, but the project needed finance. George was willing to help, and what caught his imagination was the idea that the railway would be powered by water. He agreed to buy shares in the new company so that work could begin. And soon after, an engineer called George Croydon Marks was hired to design the railway, while a local contractor, Bob Jones, was given the task of construction. The proposed design would travel on a gradient of 58%. It would rise 500 feet on a track 862 feet long. To make the best use of the space available, the tracks were narrower than usual, 3 foot 9 inches, compared to the standard 4 foot 8.5 inches, and the two tracks were laid as close together as possible. To allow the two cars to pass, the tracks bowed out at their midpoint. Construction work began late in 1887, and by December that year, thousands of tons of material had been removed using nothing more than hand labour. It took only 3 years to complete the railway, and the total cost of the project in 1890 was £8,500, about £1 million at today's prices. The only motive force used on the Cliff Railway is the weight of water carried by the cars. There was no need for a steam engine or electric motors. The two carriages are connected by steel cables fastened to the ends of the cars. These cables are carried on rollers along the track and run around wheels at the top and bottom stations. By simply making sure the top car is slightly heavier, it will descend the hill and at the same time pull the lower car up. Each car has a 700-gallon water tank that sits below the passenger cabin. And water to fill these is taken from the West Lynn River, 1.5 miles away. The water enters a holding tank. Then a buried pipe takes it through to Lynton. And under the path leading to the top station. Here, the water enters 2 more holding tanks, from where the cars can draw their supply. When the top car has enough water, it can then travel down to Lynmouth. At the lower station, water is released from the car, and this flows out to the sea only a short distance from the mouth of the river, where it would have ended its journey anyway. When the cars travel up and down the line, a driver travels in each to control the water supply and brakes. They use a bell to signal each other when they're ready to depart. On arriving at the lower station, a buffer helps to slow the descending car. Then a clamp holds this car in place while passengers exit and enter the cabin. When the two cars are ready to depart, the lower car opens a valve to allow water to escape until it is very slightly lighter than the car at the top of the hill. If, however, the passenger load is heavier in the top car, no water is discharged at all. The difference in weight does not need to be large either. The weight of a couple of passengers can be enough to set the cars in motion. Special brakes were designed using hydraulic pressure through two separate systems to ensure the safety of the railway. The brake components can all be seen on the outside of the cars. The brake water tank, the foot brake governor, the main brake accumulator, the main brake pump, the main brake shoes, the foot brake pump, and the foot brake shoes. The main brake clamps brake shoes to the sides of the track. The foot brake uses brake shoes that sit on the top surface of the track and when activated lift the lower wheels so that the whole weight of the car bears down. The hydraulic pressure for the brakes is supplied by pumps, driven by the wheels of the car. When the cars are travelling normally, the water in the main brake system can circulate from the water tank through the accumulator and back to the water tank, so no pressure is applied to the brake shoes. You'll see the driver control this with a brass wheel. The main brake is on by default and has to be deliberately released by the driver. When the brass control wheel returns to its default position, a piston in the accumulator moves down so that the water can no longer circulate. Instead, the piston applies 2,000 pounds of pressure to the brake shoes and the car comes to a stop. The foot brake system works in a similar way, but instead of an accumulator, a device called a governor is used. Two steel spheres spin around a shaft, driven from the lower wheel of the car. When the car is travelling at normal speed, the spheres rotate near the central shaft and water can freely circulate through the system. If the car speeds up, the governor spins faster, making the spheres move outward and activating a valve so that hydraulic pressure is directed to the brake shoes, slowing the car back down again. The driver can also apply these brakes using a foot pedal. The official opening ceremony took place on Easter Monday, April 7th, 1890. The opening was marked with a procession led by the Lynton Brass Band and accompanied by large crowds who gathered at both Lynton and Lynmouth stations. The lift was opened by the Lady of Lynton Manor, and Miss June was invited to pull a lever that sent the two cars on their maiden journey. The cars were filled with reporters from newspapers of the day who commented on the splendour of the views provided on the journey up and down the line. The railway was adaptable. Initially, the cabin could be removed to allow bulk cargo and cars to be transported between the villages. There was a third station just below Lynton to allow these to be loaded and unloaded. Since it was opened, the railway has run continuously and it is still operated by the same company today. Taking a trip on the Cliff Railway is an essential part of any visit to Lynton and Lynmouth. As you enjoy the ride, consider the brilliance of the Victorian engineering and feel relieved that it has saved you a steep 500-foot climb. To find out more, visit the website at www.cliffrailway.com. cliffrailwaylynton.co.uk.